Hello guys. Python by itself is not really fast, but fortunately Python, since it has a very strong and huge community, there are so many ways in which you can make your Python script run as fast or almost as fast as C. Here we will just look for few ways where you can use the parallel computing for Python. Beware that there are many other ways to also make parallel computing in Python, and I will try to cover some more in future videos, but in this video I will simply show you how you can use the threading module or the multiprocessing module, which are kind of native to Python. It comes by default. You don't even need to install those libraries. And then I will also demonstrate joblib library, which you might have to install, but its installation is pretty easy. It's just you can install by using pip, and that also delivers speed up in your Python script. So I will quickly go through these scripts, so just follow along. So I will make a new directory. So I will use here for this demonstration I'm using Mac, but as long as you can write a Python script in your computer, you can follow along using any operating system. That will work equally well. So let's make a new script, like you can name it anything. So I will call it parallel computing, and here we have. So let's enter this parallel computing, and let's make another script inside parallel computing, and we call it threading module. We just call it threading mod.py, and let's open this using VS Code, because I prefer using VS Code for scripting, but you can open it in any scripting script editor or the editor you use. So let me open this directory inside the VS Code. So I have this, and what I will do is to speed up the demonstration, so I will just copy the whole script and paste it here. And let me just quickly show you what exactly it is it doing. I define a function to just imitate some function which takes some time to finish, like this one. By default it will take at least 0.1 second to finish one run. So then I just use the time counter. So I start the time counting, and then I start empty list tasks, and then I probably this one, we don't even need that, so let's just get rid of it. So we have like sleep times, so I put different arbitrarily taken values, and then I go through all these values of sleep time which we are defining here, and then we put it into the thread. So for putting it into the thread, we do it in this way. We tell which function is it. Keep in mind that you cannot use tell Python which function is it, like using the parenthesis, because when you use the parenthesis, Python thinks that you want to execute that function, but here we don't want to execute this function. We just want to tell this threading module that this is my function object, and you have to run it in parallel or in thread. Also you need, if you are coming from different background, like C and other languages, then threading usually distribute the program to different cores in other languages, but in Python it doesn't do that with threading, because you might have heard of GIL, global interpreter log. So in Python it simply stays in one one process and then thread it. So it uses some it smartly distribute the tasks within just one process and save some time. Like, so if I demonstrate you, then it will get more clear. So the way to put the function in thread is super simple. As you can see, I just use the threading module, and from there I use the thread and I define the function, and then I put the arguments, and then I start it, and then also I add it to my list later, because we want in fact, you can, if this function is returning some values, you can also obtain that using the join. We'll see that later. So this one, we just run it and we wait for each of the tasks to finish, and that's it. So let's quickly run this thing. Okay, so we are here. So what we'll do is just run threading.mod, and task finished in 1.50 seconds. What will happen if we run it without threading? So let's just do that quickly. So I will just comment these lines, and instead of doing this, we run my awesome function with the argument sleep, and that's it. So let's see how long it takes. So this time we might have to wait a bit longer, because last time we were trying to run it in a thread, so it finished in 1.50 seconds, but this time it took 9.94, which is expected because we asked the Python to sleep for like 9.9 seconds. So if you run it in conjunction, then it will take 9.9 seconds, but if you run it in thread, depending on your system, of course, because some systems performs in a bit different, slight different way, not much, unless your system is really old, but more or less the proportion would be same. So this is how you do simple threading, but there are sophisticated way of doing threading as well. So you can in fact use concurrentfutures, which I will show you, probably not for the threading, but the threading and threading process for using concurrentfutures will be almost same. But before that, let's show the multiprocessing thing. So let's import this. Let us make another one. I will revert it back because we don't want to run it linearly, we want to run it in thread. So let's make another function and call it multiprocessing mod.py, and let's call it multiprocessing1. And then if we import the multiprocessing, and you can check how many CPUs you have. So if I just do Python multiprocessing1, and you can see that I have 12 CPUs in my computer. That will affect, because if you have more CPUs, you can divide the tasks between many processes, so your performance will be much better than mine. So let's do a similar thing in this multiprocessing, using the multiprocessing module. So I again define the same function, and here I just run it using this time it's running without multiprocessing. So if I run it linearly, you'll see that it will take some of these like 1.4 seconds. and that's what it took. But if we divide it using multiprocessing, so let's divide it into using multiprocessing. So you can I'm just telling the multiprocessing process method that my function is my awesome function, and since we already have the default values, so we don't even need to provide the function here, which you can in fact do in the same way you did it for the threading. So here we just need to start it. We don't want to run it sequentially, so we don't even need to do the join method. But if you want to run it sequentially, you might be interested in doing p1.join and then p2.join and then p3.join. So we'll see that in the next script, but before, let's just run this one, and you can see that all these functions finishes 0.1 seconds because all of them ran in parallel, and each one took 0.1 second because that's the time one of them will take. Next, we can also join it because you can here for multiprocessing, any process can finish before the other one, but sometimes we need it to finish in a sequential manner. We need first one to finish and then the second one, so you can in fact use the join method to do that. We can let's try this one, the similar thing which we did for the threading. So let's paste again. We define the time and we sum all of the times to figure out how long it should take if we run it in a sequential manner, and then we'll run it in a parallel using the arguments and see how long will it take. So let's run it. So in a sequential manner it will take 9.9 seconds for the 16 tasks, but in fact using the multiprocessing it took 1.5 seconds. It is in fact the same sleep times list which we use for the threading, and you can compare, like for the threading it took 1.5 seconds and multiprocessing took a bit more than the threading. So multiprocessing is in fact better for the CPU bound tasks, but for the IO bound tasks you might prefer to go for the threading. IO bound tasks are usually where you open the files, download something and those kind of stuffs. So for those kind of stuffs, in general you would prefer going with the threading, but for the CPU intensive where you do a lot of computations, you might prefer going for the multiprocessing module. Okay, so now let's see how we can do this using the concurrent.futures. This is in fact more elegant way of doing the same thing. Here sleep times we define it randomly, but if you want we can use the same list. It will work almost in a similar fashion, and we use concurrent.futures, and then we also we instead of using the join method we use concurrent.futures.asCompleted, and then we get the results. So let's run this one and we get the results as well because we have the sleep time, and it took almost same time. In fact it depends a bit. Probably it might be a bit more expensive than just using the start and join method, but this is more elegant and much more handy to use because you can easily obtain the results, the returns of the function. Okay, now you can also use the map function to do that. So let's simply copy this and paste it over here. So what we are doing, let's go through again. Here we randomly define the sleep time, and then instead of doing if you wanna run it in order, then we might wanna use the map method, and then let's run it. And in fact we finished it much faster than, but keep in mind that this is not the same sleep time, so every time you run it, it may vary, but since I'm using the seed value of 0, so my sleep time will be same. Sleep time list will be same each time I run it, so it should take almost the same time as before. So that's how we use the threading and multiprocessing. For threading, if you wanna use the concurrent.futures, you can do that. So let's see how will you do the concurrent.futures for threading. So I will just paste it over here, and I just wanna add this concurrent.futures. We don't wanna use threading anymore, and then maybe we can get rid of these things. We keep the sleep time same, and let's get rid of these. Sleep time, we already have defined the function. We already have these things defined, so we don't need this. Now instead of using process pool executor, we use process thread executor, and so we can simply use the thread pool executor, and we submit the task. So we tell the awesome function, we tell the sleep time, and we append that, and then we wait for the results, and that's all. So let's run this one. Great. Since it's returning nothing, so and we are trying to add the return into all results, so but in fact we can return something. So let's say if we can return anything, we can call it sleep time is I can use the F string. So sleep time is sleep time, and that's it. If we run the same thing, we should get different values of the sleep time. Great. So that's how we use the multiprocessing and the threading modules. Next, we want to quickly have a look for the joblib module. Joblib library provides a set of tools for lightweight pipelining in Python. So one task finishes, and the result of that task goes into another task, and then it performs faster in that way. It's kind of an optimization to reduce the total computation. So let's quickly see how the joblib behaves. So we'll copy the script. Let's make another one. Okay, so we have we imported the parallel and delayed from the joblib. We defined a function with the two variables this time, and we take the square root of the two variables, the square root of the square, and then sum it. But to delay the computation, we just add the sleep time. So if we check how long the joblib takes to compute, so simply run it in parallel. We tell the joblib to use the number of CPUs we have. So for that we can simply use CPU count from the multiprocessing. That will figure out how many CPUs your system has. Sometimes for long tasks you may not be interested in using all the CPUs, so probably using like only 80% of the CPUs may be a better idea. You can like try that. But here and we tell the backend to be multiprocessing. There are a few other backends available. I'm not sure. In fact, we can quickly have a look. So they have like Loki, which they use by default, and then the multiprocessing, which we're using here, and a few others. So if you're interested, you can go and have a look at it. For now, we simply run that, and same thing, we do it using the NumPy and see which one's performing faster. So we just run joblib. See, joblib, since it's not a built-in function, so you might have to install it. So let's do that. So for installing, we can simply do pip install joblib, and that's it. We get the joblib. Now we can run it, and you see that joblib finished the same task in 2.61 seconds, and NumPy, which is also quite optimized and runs much faster, took definitely more than 2.61, but let's wait a while to figure out how long it took for this run. So it took 30 seconds, which is crazy because it's almost like 15 times more than the joblib computation time. So the joblib may come really handy in your codes. So that's it, guys. Thank you for watching. Please don't forget to like and subscribe the channel.